This is House Planning Help episode 66. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're interested in building a house or perhaps renovating one. What exactly should we be doing? I'm exploring the best practices by speaking to industry experts and also people who have been there and done it. Alongside this, I have a personal goal, which is to create an energy efficient home before August 2016. And we're into August 2014 at the moment. In fact, we'll have a little update in a moment, but let's tell you about today's session. My guest is Stephen Gurney from Ecological Building Systems. We'll be looking at the main reasons why airtightness can fail. So as I mentioned, I'm coming up to my 38th birthday now, and a couple of years ago I set this big goal to create an energy efficient home before I turn 40. So that gives me 2 years left. I feel this last year I've drifted a bit. Things have been busy, they always do tend to be. And I'm sure I have built up my knowledge a lot, but I'm definitely ready for some action now. We've 2 years of research, and I know they always say 3 years of research and 1 year of actually doing the project, or a lot less, a lot more focused, but I'm not sure that I've been doing exactly what they've been suggesting in that. So I want to move things on. And I've had this really weird situation. It's some good fortune that is mixed in with a weird twist. So I just want to be open with you and tell you about it, because for some time I've been a part owner of a piece of land. It's nowhere near to me. It's been a piece of land that I actually, I'm a silent shareholder. I can't do anything. And for about 20 years, they've been talking about selling it, and I haven't been that interested. Secretly, at the back of my mind, I was thinking, well, maybe one day I'll be in a position to do something with it myself and get some houses built there properly. But then out of the blue, this land has just been sold, and I have no idea who it's been sold to and what's going to be built on this piece of land. So I have definitely benefited out of this. It's certainly going to bolster my budget when I come to build the house. But at the same time, it makes me look like a hypocrite. So it's a weird situation. And I'm definitely not in the stage of my life that I can say, oh, well, I'm not going to accept the money or try and stop all of this. I just can't. I'm not there at that stage. And it is possible, if they are going to develop this land, whoever's got it now, that it will take several years. And maybe one day I'll be able to buy it back if I'm in a much better situation. Hopefully, I can use the extra injection of money that's come in for positive effect. But yeah, an odd situation. So strange start to the podcast. You haven't heard one like this before. Yeah, odd. Let's get to today's interview, and it's with Ecological Building Systems. They're one of the corporate backers for the Kickstarter documentary that we're making at the moment. And I thought, well, these companies have been great. I really want to get behind them. And as a bonus, I didn't tell them this beforehand, but I just gave them the opportunity. You can come on the podcast. We'll speak to one of your experts. And that's exactly what we're doing today. Stephen Gurney is very knowledgeable when it comes to airtightness, and he does a lot of training. He's going to tell us more about exactly what he does. It just seemed obvious to tap into his experience to find out why some buildings achieve great airtightness results and others don't. First, though, I asked him how he came to specialise in this area.
I've worked within the building trade for many years, and then around about 6 years ago I became more interested in ecological buildings and sustainability of the materials, etc. Got into natural materials, worked with a company supplying wool, and then I started with Ecological Building Systems 4 years ago, dealing with a range of products and looking at the technical side. So I deal generally with the technical side of airtightness and vapour control, and how we apply it on site and how we design it into buildings, and then the actual training with the guys who are applying the materials.
On this podcast, we talk about airtightness quite a lot. And so I always assume that people know why we're talking about this. In case someone's coming in cold, why is airtightness important?
Well, airtightness is all about creating an envelope around your building to stop loss of the nice warm air that you've created, and also to stop cold air pushing into the building. So if you imagine the more air you're losing out of the building, the more you're having to spend on reheating the cold air that's pushing in. So it's basically getting rid of the drafts. Obviously, when you get to very low levels of airtightness, you then need to look at your ventilation system. So MVHR, mechanical ventilation with heat recovery, is the best system, obviously, that you can put in, because it's very energy efficient. It's reheating the stale air that goes out with fresh air that comes in. But airtightness is all integrated into that, because if you've spent an awful lot of money on an MVHR system, if you've got very poor airtightness, it can actually mean the efficiency levels of the MVHR will drop right off. So it should be working a good system around about 90% efficiency. But if you're introducing cold air from around the building and it's not going through the system, it's actually making it very inefficient.
We're talking today about why airtightness might fail, or some of the reasons why it might be compromised. So maybe we could talk that through the design stages, also the installation, materials, etc., and even from when the user is left with the building. So take us through that early stage of the design. How do we know that we're going to get a good airtightness design so that when it comes on site, it's all going to work perfectly?
I think the designer it's a joined up approach. So it's looking at each element of the building. So the walls, the roof. You'll have an approach where on the wall you'll have something like a membrane on the wall, and a membrane on the roof, and a concrete slab on the floor. But it's actually, a lot of it is working out how you're going to join all those different elements up. So we've got a membrane on the wall. We've got this slab here. How are we going to connect the two together? What we're going to do? So that needs to be designed into the build, and there's other elements. If you've got things poking through your nice continuous envelope, so like soil vent pipes, electrical cables, etc., it's looking at strategies for that. So there are grommets from the Proclima range, and that will deal with both of those elements. So you can seal around them properly, so you've not got air leakage from around there.
Just going back to your example that you gave, so the concrete would be airtight because of its nature.
Yeah. So you could use this, as long as the slab is continuous and you connect into a continuous slab, or alternatively, some people connect to the DPM, so they'll bring the DPM up from...
What DPM?
A damp-proof membrane. So bringing the damp-proof membrane up to join with the membrane above. So we would tape the one to the other. So you've got a membrane underneath that connects to the membrane on the wall, or you connect to the slab, bringing that around with a glue such as Orcon F.
And there will always be a membrane on the wall.
It depends on your construction type. So with a timber frame, it could be a membrane, or you could be working with a board. There's an airtight board called Vapor Block, for example, which you would tape all the joints of the board, and that forms your airtightness on the inside. So it depends on the build type, even with timber frame. So that's the racking on the inside. So the strength is on the inside of the timber frame wall, but you may have a case where the racking is on the outside. So the boards will be on the outside of the frame, and then you would form an airtight layer on the inside with a membrane.
And when we're dealing with different elements, you talked about what we might have. Let's say, for example, it's a window. Will we always be taping around that, so join that one thing to the walls, for example?
Yes, so you tape every element. So a window, it has to be joined. You have to look at how you join that to the wall. So you could be a masonry construction, but you would still use a tape to connect from the window to the wall. So we have a tape called Contiga SL, for example, that would do that. And it's important because you could spend an absolute fortune on a really good triple glazed window, and then the installers come along, bung a bit of foam around it, put a bit of silicone, seal it, and then walk away. And you think, well, that's okay, but what happens over a few years is everything shrinks back, and you start to get leakage from around your very expensive window. So you've actually got a bypass. So you've got £1,000 worth of window working brilliantly, but then there's air flowing all the way around the outside of it. So it's an important and integral part of making your building efficient and making all the expense you've laid out for the windows, etc., to work properly.
How do you spot these leaks then, particularly if they develop over time because of poor installation?
It's the good old-fashioned draft, I suppose. It's on a windy day, you would feel it, or on a very cold day, you always get negative pressure, so you'd feel cold air pushing in from around these elements. In the build process, the best way is to depressurise the building. So an early on air test, if you can, when that air test is going on, you'll be able to actually feel at negative 50 pascals, you will feel the air being sucked into the building. You'll feel it around any element that's leaking, or there are small smoke guns, etc., that could highlight it. If you're very much down to low levels, sort of like passive house, where you've got to identify very small leaks, then you may use a smoke gun or something like that.
And that actually goes on as a checking process. So if they're concerned, the airtightness isn't down to 0.6, they will go around looking for where all these points are, and you have to make sure that each one, it's the equivalent of patching up little holes. It's like that.
Yeah, it's patching up the small holes, really, and they only may be quite a small hole, but if it's repeated throughout the building, then all those small holes add up to quite a large hole. So it's especially down to passive house and 0.6 air changes per hour, it's very important to test early. So you get a test once you've got your building fabric in with the windows in, etc. That's the point you would test. You would never leave it to the end till all the finishes are over, because you wouldn't be able to identify where the leaks are. You might have a leaky building, but you can't spot them because they've been covered over, more or less.
And when we're looking at these different tapes and membranes, in my mind, it's all plastic. And what are they made of?
Well, there's various ones. I mean, the membranes, as you say, they do have a plastic element to them. We have a more natural membrane, which is DB+, which is a cellulose. So it's
more expensive?
No, it actually works out. It's slightly cheaper, but it's widely used in Germany. They like it there because you can fold it into the corners, etc. But you can't see through it. So when you're actually trying to apply it to the studs with staples, to the timber with staples, you can't see through it to see where the staples are. So you need to be well organised. So a good German builder is always very well organised. They'll know where everything is, so they can actually put the staples in the right place to apply the membrane. But And there is a difference in the way they work. The Intello Plus is an intelligent membrane, as is DB Plus, which means they allow a drying in the summer months into the building. So if you get moisture within your fabric, it gives you a fallback position where you can get some drying into the building, which obviously will windows are open, etc., will dry out naturally. Intelligent membranes is a whole subject in itself. I could probably take about half an hour talking about how they work. If anybody's interested, we're very happy to speak to them about it, but I don't know whether we have time today to talk about it.
Well, I know that you mentioned vapour control. This might be moving it on a little bit, and I almost got what you were trying to say, but will that be in the airtightness layer that we apply?
Yes, the vapour control and airtightness should work very much hand in hand. So both are trying to stop air moving from inside of the building or to the outside, for example, so we're not losing air. And if you are losing air and it's the air from inside the building, it's warm, moist air, but it's quite stable. It's humidity levels around about 50%. But if that breaks through our envelope, what happens, it will hit a cold point at some point in your structure and condense there. So you actually will get water then gathering within your building, and then you've got a risk of mould and rot, etc. So in a way, vapour control is more important than airtightness because it prevents moisture gathering within your structure and then putting the building and the occupants at risk from obviously moulds, which asthma is a well-known result of mould gathering within building, or asthma sufferers get much worse when it's there. So I think airtightness, when you relate it to loss of air out of the building, you're reheating that air, so there is a cost to it. So that's going to affect you in your pocket as such, but the actual vapour control level should be right to mean that the building is a nice, safe structure and a nice, happy place for people to live, really.
Let's talk a little bit about these materials again. Presumably they are still relatively new, so how well have they been tested, or are we expecting that 15 years down the line we'll think, oh, actually this didn't work, it might have been stress tested, but are they going to be a long-term proposition?
Well, I think it's basically down to the what's used within the materials. So, for example, the tapes that you may use for the overlaps or for the joints on a board, all the tapes that we supply for that are solid acrylic tapes, so the glue is very, very good. It's the sort of glue you would find in the aeronautical industry, so they're holding various sections of plane wings together. And it's used because they're very stable at different temperature variations. So a plane at full altitude may be at -40, and then on the apron in Saudi it may be 100 degrees. So the glues have got to take those stresses. So within our buildings, that's why we use the glues, because they can take a high variance of stress in that way, and they're very good with humidity as well, and they're very good in the long term. So testing wise, ProClima in Germany have accelerated tested up to 100 years now. So we've got data that can say up to 100 years of testing in that way, and they've got on-site testing now of 16 years. So they've gone back to tapes that were applied 16 years ago and looked at them in situ and just checking all the adhesions there. Because this is important. You could think, I'll use a cheaper tape, and then it's fine. It maybe stick at first. It might not stay stuck once you depressurize the building, your air test. But say it does work in that way. What will happen over time is the glues will dry out, become brittle, and then the tapes will stop functioning as air barriers. So again, you had a lovely design building that was going to work in a certain way, very energy efficient way. But if you put the wrong material in, that will over time the building will perform less and less well. So the energy efficiency will drop off.
And I'm imagining it's not as simple, we'll go back and retape that. It's a huge job.
Oh, yeah. Well, once it's all covered up, you imagine to try and strip back a building to its bare bones as such it wouldn't be worth doing. So it's all about doing it right at that point where it's exposed. Put the right materials on. You'll find it easier to use them as well if it's the right type of tape, because it will stick immediately. You'll get an immediate tack, even if it's quite on a build. We sometimes get where the humidity is quite high. You'll get a tack there on the build. And the tapes that we use are also waterproof. So if you've got an element where you've got certain elements that are open to weathering at certain points, so if you haven't quite got the windows in, once the tapes have adhered and cured, they're waterproof at that point. I find on lots of sites there's builders with various bits of tapes over trousers that have been torn, and they come along and tell me that they've been through the washing machine about 5 or 6 times, or 10 times as I heard the other day, and they're still working, they still stayed stuck. So there's a bit of on-site verification of their durability.
Are there any other big no-nos or situations that you've seen where the airtightness has been compromised, and why was that? It's
down to poor education of the people that are handling the materials, so nobody explains why they're using them. So you could go onto a site where a builder's just been handed a roll of tape and say, go and tape that up. There's no relevance to it for him or her, because it's just taping something up. They don't know that they've got to apply the tapes correctly. They don't know why they're applying them. Nobody's explained the efficiency of the building relies on it, and the vapor control relies on it. So I think it's education at that point. And then we will do toolbox talks on site, etc. So we spend a bit of time with the guys or girls that are applying the tapes, or if it's a self-builder, a lot of the times that self-builders will be applying the tapes themselves. It'll be a job that I think they can handle. We'll work with them over the phone. We have videos, or if we can get a site visit in, and we'll do that. But there's lots of information out there. We have lots of videos on the site, on our website, that explains how all the systems work. So there's help there.
And I think I saw you when I was making one of the videos for this year's Passive House Awards, and this was the one that won in Scotland, Kirsty's project. And I was sorting through some photos she gave me and thought, I think that's Steve in the background there.
Yes. I was doing a toolbox talk there for the guys there. So, and they were really good builders, actually. It was Hope Builders, I think they were. So it was the first job that they'd done to this level of airtightness, to passive house levels. So they really got behind it. They paid attention.
They embraced it. I remember what Duncan, the homeowner, was saying, how it was actually very, very difficult to find someone who, they admitted it, they didn't know everything, but they were willing to learn. And I guess that's got to be a key thing with anyone that you hire, that unless they have previous experience, they've got to want to do this. Yeah,
they've got to want to do it. And take on board what's trying to be achieved. It's also having somebody on site that's on top of it all the time. So we call it an airtightness champion. So as a self-builder, it might be yourself, or if you're employing a contract manager, it may be them. Somebody that's there from the start to the end. So that's looking out for all the points where somebody's coming and either applying the materials correctly, or somebody later on when your plumbers and electricians are coming, they're not poking holes through your envelope, your nicely sealed envelope, and ruining your airtightness. So it's being on top of that job and explaining to people what there is an envelope, an airtight envelope that needs to be maintained.
And as a homeowner, have you come across situations where that envelope has been penetrated over time, either because of the ignorance of the homeowner. And with self-build, it's slightly different because I'm sure they'd be very protective over the thermal envelope. But if they'd moved into one of these properties and themselves didn't quite understand it.
I think there is an element of that as the people that are moving into. I think with self-builds or with somebody that's aware that they're buying a passive house, by that time they will have bought into it, so they have a certain awareness. I think within social housing, where lots of passive houses are now being built, I think there needs to be a communication to the new tenants as to what the building's doing and how it works, and to not go randomly poking holes through, because it will affect how efficient the building. If you tell somebody that it's going to affect the bills that they pay if they're just going to poking holes in the building, then I think they'll be on board on it. So it's a very fairly simplistic explanation as to what's going on with the building and why it's different to the last building that we're in.
Now, I don't want to open a can of worms just as we get to the end here, but retrofit, I suppose in my mind we've been talking about new build. How do things change with retrofit?
I think retrofit, it is, as you say, it's a bit of a minefield.
Don't worry too much.
No, but I think it falls into two categories. You either look at if you're applying insulation internally, you look at very diffusion open material that works naturally with the building structure, something like Calcitherm or Gutex Thermaroom, which are a wood fibre. Calcitherm is a calcium silicate board. So they're very capillary active. They will move moisture away from the wall, etc. And I think if you are going to build a stud system with inside your building, so you're creating a timber frame with inside your actual stone or brick building, I think it's very, very important that you've got to fully seal. So you have to make sure your vapour control layer is actually sealed all the way through and it's all joined up. So you're making a fully sealed envelope within the building. Otherwise, because your external wall now has become much colder, so your risk of condensation gathering against that has risen to a much greater level than you would expect. So I think it goes one way or the other. You either seal completely on the inside with a very good vapour control and airtightness layer, or you go with an internal insulation that's very diffusion open that allows moisture in and out of the wall.
Just a little curveball at the end there. Any final thought that we should think about staying in control of airtightness, making sure that it doesn't get compromised?
I think it's just this attention to detail, especially with airtightness. It's for very low levels, sort of to passive house, even the small little bits, the corner that might be what you would consider as a tiny little hole. If you add that up over 10 windows and you've got every corner, you've got 4 of them on each window, so you've got 40 in total, that's where your airtightness will fail. And so it's just looking at those small details and just think about how you join this to this to this. It is a matter of just joining things up and working out how you're going to join them up.
Steve, thank you very much.
No problem at all. It's been great.
You can find today's show notes at houseplanninghelp.com/66. We've got a link to Ecological Building Systems. You can go and check them out and find out exactly what they do. Also, Stephen has provided some cross-section diagrams of the airtightness layers and how they might vary. And if you haven't seen the membranes and all the tapes that we've been talking about, this will give you a really good visual representation. If you've got a question for him, you can leave it at the bottom of the show notes in the comments section, and maybe we'll try and bring him back to answer that, anything to do with airtightness. My call to action today is for you to come and follow me on Twitter. I am at Ben Adam Smith, and it's something that I really love, the interaction side of things, constantly having a conversation, and I do my utmost to reply to every tweet. So send me a message telling me which of our podcasts has helped you the most, and that will also be a little bit of interesting research for me too. Next time, Graham Hunter from Parity Projects is my guest. It's part 2. If you've listened to the first section, we did an energy assessment, well, actually, of my dad's house. So we're going back there to look at the results and see if my dad is actually going to implement anything on this report that they've done. I hope you can join me for that one. Cheers.